Welcome to our class in quantitative methods, where we're going to look at the first important parts of QM. And so to start with, I will need to explain to say quantitative method is paramount to all researchers who want to understand how to describe information, to give a statistical review of the pieces of data. There's a difference between data and information. Data could just be pieces of figures and numbers and symbols, and information is simply processed data. And so we're going to start with firstly understanding what qualitative data is and what quantitative data is. So from the term, we need to understand that quantitative data refers to quantifiable data, numbers that can be counted, can be measured with a numerical value. These are statistical figures, whereas qualitative, we're dealing with descriptive information in nature, which can be expressed in languages, even numerical values. For instance, your NRC, that is not quantitative, it's qualitative. If we're dealing with figures, we're going to subdivide our quantitative data into two. We have what we call discrete and continuous. In a layman's language, if we're dealing with discrete data, we're looking at countable non-integer values that have no decimals. Discrete data, for instance, we're dealing with the number of children in a home, you have 5. The number of times you attend class, maybe 6 in a month, those are countable. Whereas continuous is a quantitative measurable inference, which has integers or fractions or decimals. For instance, your weight, which could be 2.5 kg, the temperature, which was 35.6 kg, that is all quantitative but continuous. Are we together? Then when you're dealing with qualitative data, we're looking at ordinal or nominal data. Nominal data is as good as discrete. It cannot be in between. For instance, a place of birth, you can either be born in Zambia or you're born in Angola. That is nominal but qualitative. But if we're dealing with ordinal data, we're looking at an intersection of two. You can be a mixed race. You can be mixed tribe, Tonga, Bemba, that is what? Qualitative. And yet, ordinal. So basically, you need to understand some pictograms as well. So a quick, can you remember? I've talked about 2 types of data. Can you remember? What types of data do we have? We have what? Quantitative and qualitative. What's the difference between quantitative and qualitative data?
Quantitative is quantifiable, can be counted.
Good. We're looking about quantities. Whereas qualitative, we're looking at quality. Okay? So you need to distinguish between quantitative data and qualitative data. So far, are we together? Now, can you give me examples of quantitative data, 2 streams of quantitative data?
Your mic muted.
No, you can speak. Okay, give me examples of quantitative data. So I'm going to give you 3 statements. You tell me what type of data it is. My child weighs 2.5 kgs. What type of data is this?
Continuous. Quantitative, continuous.
Exactly. It is quantitative data because you are able to measure it. Under quantitative, we're dealing with what? Continuous, because these are integers. Okay. It can be an integer. It's a decimal point. The quality of teaching that Dr. Sabayo exhibits in class, what type of data is that?
Qualitative.
Qualitative.
It should be nominal, I think.
It should be nominal. Is that right? All right, so help me answer these other questions from the question bank. Then we go to the descriptives, then we proceed from that angle. All right, there are these questions here. The weight of baby given in kilograms, varied answer quantitative, continuous, it's an interval. How about the country in which you're born? This is what? Quantitative and nominal. How about for each day of the year, the difference between the maximum temperature and the minimum temperature? What type of data is that? That is quantitative because you can measure temperature, but it is continuous because it is an interval. It can be melting, it can be freezing, and these are the points, all right? So this is the first segment of what we call data organization. So we'll go further on in understanding what we call pictograms. So we have 8 types of pictograms you need to know. We have what we call a pie chart. Those who eat pies, you could see, you know that these ones are measured in degrees 360. Who can tell me what type of pictogram this is?
A bar chart.
So this is the bar chart, all right? Bar chart looks like that. It has spaces. And this is, and what type of data is this? What type of pictogram is this?
A histogram.
Histogram, correct. And the line that joins the midpoint here is called a what? An ogive, right? Okay, quickly, what type of data is this? What type of polygon is this? Cumulative frequency, because this is accumulating, it's going upwards, right? And what type of polygon is this? This is a relative frequency polygon. All right. What type of polygon is this? The box whisker.
Box and whisker.
Yeah,
Boxer.
it's a box whisker. Okay. I'm glad at least you're not as blank. And what type of figure is this? 0, 1, 2, 1, 1, 2, 2, 4, 6, 3. What is this?
That's a stem and leaf.
Good, this is a stem and leaf diagram. Okay. So then if we draw a box whisker plot and we discover that we have an element that is outside this box, like at X, what do we call this element outside these extreme values?
That's an outlier.
An outlier.
It's called an outlier, correct. So this is what we're expecting to have in the whole syllabus. And we'll also have something that looks like this. So polygon. Who can remember this? 0.2 here, 0.8 there, 0.2 there, 0.9 there. What is this polygon?
That's a tree diagram.
Yes, this is it's a tree diagram. So we'll find this in probability. It's a tree diagram. All right. So now let's get to serious business. We now get to our question number 2. So we've been given the following data here. We're told that we have foreign language enrolled by 20 students, where we have Spanish, we have German, we have French, Russian, and we're being asked to come up with what is called a frequency distribution table, a histogram. So how do we come up with such pictograms? So we need to summarize our data. Okay, so we have the following languages. What languages are there? We have Spanish. And use a tally. Maybe find the frequency. Then we also have French. What else do we have? German. What else do we have? Italian. And we have Russian. How many Spanish do we have? We can cross out 1, 2, 3, 4, 5. So this is how we do the tally. 1, 2, 3, 4, 5. This means it is 5. All right. Then we can go to the French. How many are they? 1, 2, 3, 3. 1, 2, 3. So this is 3. All right. We can go to the German. How many are the Germans? So we go here. 1, 2, 3, 4, 5, 6, 7. So telling we do 1, 2, 3, 4, 5, 6, 7. Immediately the 5 we cross out. So 7 looks like that. All right. Are we following? Then we go to the Italians. How many? 1, 2. 1, 2. So we get our 2. And finally, we go to our Russians. So Russians, we have 1, 2, 3. So we have 1, 2, 3. We'll put our 3 there. Okay, so these must add up to 20. So to prove that, we can come up with what is called a cumulative frequency. Cumulative frequency, we keep adding on. We start with a 5, add on the 3, we get 8, 8 add on 7, what we get? 15, 15 add on 2, what we get? 17, 17 add on 3, we get our 20. And our 20 is our n here, which is 20. Are we together? Before I proceed, anyone behind? Seems we are following. Then we can also come up with what is called the relative frequency table. So relative frequency, we're just dividing this over the total. All right, so 5 divided by 20. What do we get? 0.25. Then 3 divided by 20, 0.15. 7 divided by 20, 0.35. 2 divided by 20, 0.10. 3 divided by 20, 0.15. The total is supposed to be 1. You can also come up with what is called a relative cumulative frequency. You start with bringing this 0.25 here. Then you add on 0.15, what we get? 0.40. 0.40, you add the 0.35, what we get? 0.75. 0.75, when you add a 1, we get 0.85. 0.85, we add the 0.15, we get 1.00. So this is how we draw our frequency distribution table. So I'm trying to teach 3 lessons in one so that you could get the concepts as much as you can here. If we're dealing with a pi, we just multiply our relative frequency times 360. So to get the degrees, the pie chart for the Spanish, what's the proportion of the Spanish? 0.25 times 360. So this is 90 degrees. For the French, 0.15 times 360 degrees, we get 54. For the Germans, 0.35 times 360, we get 126. For the Italians, 0.10 times 360. What we get 36. And finally, for the Russians, 0.15 times 360, we get 54. The total here will give us what? 360. So this is how the pie chart can be illustrated. Any questions so far? Anyone behind? Are we following? Are we moving together? So you will be asked to draw the polygons. Suppose you're being asked to draw the relative frequency, the cumulative frequency, and maybe the ogive. So in this case, we're dealing with what? Letters here. S, F, G, I, R. S, F, G, I, R. So in this case here, we have the frequency. So ideally, what I just want to talk about is this. Since I told you how each of these polygons look like, the cumulative frequency, no matter how we are going to sketch it, needs to come out something like that. It doesn't fall down, it accumulates. The frequency polygon will be zigzag. So whatever you're going to plot it against, it should come out something ugly like that. So at least even your answer, depending, no matter how wrong it comes out, it should be within the correct idea of the framework. You'd be given data that is not grouped. 42, 25, 10. So this data will be asked to calculate the measures of central tendency. Let's come up with the mean, the variance, and the standard deviation. So these are the values of x. The values of x squared, you're just squaring these answers. Here we have 16. Here we have 4. Here we have 4. Here we have 25. Here we have 100. So let's total up. See the totals we're going to get. So 4, you don't need to arrange for this one here. 4 plus 2 plus 2 plus 5 plus 10. So we're going to have a summation of x to be 23. When you add 16 plus 4 plus 4 plus 25 plus 100, you get 149. And each of these ones here, when we find how many elements are there, 1, 2, 3, 4, 5, our n is 5. So we're going to come up with the measures of central tendency. The first one is called the mean. The mean has a symbol called x bar. This is the sample mean. If you're using population mean, you use mu. Formula is summation of x over n. So here we're going to have 23 divided by what? Our n is 5. So what do we get when we compute that? Our mean becomes 4.6. Then we have a variance which has the symbols for a sample, s squared, for a population, it's sigma squared. So the formula under sample variance is summation of x to the power 2 over n, everything over n minus 1. If you do n, that is population variance, so this is s squared. But it's a sample, you do n minus 1. Question, how do we know whether it's a sample or it's a population? Okay, so here, x squared, here we have what? 149 minus 23 to the power 2. Our n is 5. Everything over 5 minus 1. So be mindful of your calculator. Let it not rob you of the marks. So be careful. If possible, do the grade 1 way, where you're going to do it individually until you get your answer, which is 10.8. So you start from here, 23 squared divided by what? Divided by 5. It's going to give you 23 squared is 529 divided by 5 to give you 105.8. So later you're going to have 149 minus 105.8 over 4. So 149 minus the answer divided by 4. It gives you 10.8. So this is what we call our variance. Please, if you're behind, raise your hand so that I can explain or repeat what has been said.
Sorry, we just go through that again.
All right, so I'm just explaining how to find the variance. The variance comes in two ways. We have a population variance. It has no n minus 1. This is just n. We have a sample variance. It is n minus 1. So from the data statistics that we collected here, the formula for the variance is summation of x to x squared and summation of x to the power 2 over n. Everything over n minus 1. So there are two x's people want to confuse here. The x squared is a big value. This is called summation of what? X squared. The small value is simply summation of x. So where there's x squared, we put 149. Where there's small x, we put 23, but this is in brackets the power 2. So 23 the power 2 over 5, it will give you 105.8. Then 5 minus 1 down there will give you a 4. When you compute this minus that, you press equals because your calculator is in board mass. Then divide by 4. That's when to give you 10.8. So this is called our variance. Variance has several formulas, so you need to know which one to use, but this one is the easiest. Are we clear now?
I have a question.
Yes,
Had
please.
we been calculating for population, would we have divided everything by 5?
Yes, we'd have divided everything by 5, correct.
Okay.
Any other question? All right, so standard deviation is simply given by the square root of what? Of the variance. This is sigma, or the letter S, which is simply the square root of S squared. And we found our S as 10.8. Square root that, we get 3.286. Preferably leave it to 3 decimal places. But this is how we find our standard deviation. Then we have what we call the coefficient of variation. Coefficient of variation, or commonly known as CV, is given by standard deviation over our mean times 100. So it measures the percentage by which we are deviating from our expected value, which is our mean. So we have calculated our mean as 4.6. So the higher the CV, the more the risk, or the more variation. So here we're going to get 7.21.44%. That is our CV. At your level, you may not be asked per se to interpret, but if you're using two assets, asset 1 and asset 2, and you get maybe 20% here, I'll teach you this in your second level as you'll be taking corporate finance. You'll be asked to interpret what is the significance of this. So between the two, risky asset is asset 2 because it has a more coefficient of variation, which means it has a more risk. It is very volatile. It is unstable. It is risky. All right. Any questions at this point before I proceed? Yes, Chimo.
Yes, please. A bit behind on how we found the, is it 10.8 something there?
The 10.8 is what we calculated here, the variance. So when you square root this, the name changes to standard deviation.
Okay, thank you.
Any other questions? All right. Now we go to what we call the measures of what? Dispersion. Now, in these measures of dispersion, we undertake to rearrange the data using order of ascension. So it could help me to rearrange this information starting from the smallest to the biggest. Can you help me? What is the smallest value there?
We have 2, 2.
Okay.
Then we
have 2, 2.
Then 4, 5, 10.
4, 5, 10. All right. So this is our new data set. So we have a lot of measures that we can calculate. So we can start with our range, which is the difference between the highest number minus the smallest number of x. So here, our highest number of x is what? 10. The smallest number of x is what? 2. The difference is 8. And so we call this our range. Half of this is called the mid-range, if you want. The mode is simply the most appearing variable, the number that appears the most, which in this case is 2. 2 is appearing the most, so that is called our mode. Then we go to the quartiles. We have quartile 1, which is simply a quarter. We have quartile 2, which is simply half for 2 quarters. We also have what? Quartile 3, which is the third quartile or the upper quartile, which is 3 quarters. So we have 1, 2, 3, 4, 5. So we multiply this by n. All right. So whenever we get a decimal, we round up. So what is a quarter of 5? So n is 5. What is a quarter of 5? One point what? 25. So we're going to round up this to the nearest whole number. Our number is 2, the second value. So our second position, if it's rearranged, our second position coincidentally it is what? 2. So our Q1 is 2. That is called our lower quartile. So the second one is half of n. So our n is what? 5. Half of 5 is what? 2.5. Like I said, as long as there's a decimal point, you round up. For 2.5, the nearest will be what? The third number. So our third number, 1, 2, 3, in this case is 4. So our Q2, which is also called the median, will give you a 4. Then the third one is 3/4 of what? N. And our N is 5. 3/4 of 5. What do we get? We're going to get 3.75. So since it has a decimal, you round up to the fourth number. And the fourth number in this case, 1, 2, 3, 4. So our fourth number is 5. So these are the quartiles we're looking at. So our lower quartile is 2. Our median is 4. The upper quartile is 5. So the box-Whisker plot itemizes these things. The lowest number, the highest number, for the sake of illustrations. Here have Q1, Q2, and Q3. So the lowest number was 2, the highest number was 10. The lower quartile was 2, and we have the median as 4, and the upper quartile as 5. So this is what we call the box-Whisker plot. Of course, ideally, it's supposed to look like this. Is just for the beginners' purposes. Ideally, it's supposed to look like like this here. Because 2 in the lower quartile, they're at the same position. So it may look like this in the axis, but leave it the way I've left it so that you understand what I'm doing. There are a few who have read ahead who may want to ask why am I distinguishing these two. It's the same thing. So if you can see here, the distance from 2 to 4 has about 2 units. The distance from 4 to 5 has about 1 unit of the difference of 1. So here you can tell from the shape of the box-Whisker plot that here we have a larger space on the what? On the left side. So we can say it is skewed to the left. If we had 3 box-Whisker plots, just to illustrate, we can understand how to tell the shape of skewness. Now, what is skewness? All right. We have 2, 8, and 10. Here we have 2, 5, 10. We have 2, 4, and 6. So here, the bigger gap is here. So this is skewed to the left. Between 2 and 8, there's a bigger difference. Here, the difference is bigger between 5 and 10, so it's skewed to the right. Here we have 2 difference, and here we have 2 difference. So this is called a normal distribution. So skewness simply means echo now. If you have a normal distribution, it means 50-50. By the way,
Sorry, may I please just stop you there? If you go back to your previous page, the first one you said was skewed to the left, and it's supposed to be skewed to the right because it's supposed to be skewed to the left
yes,
because it's got a bigger value on the left.
yes, yes. So even this one, the value is bigger on the left here, between 2.
Okay.
But here 5 is bigger on the right. Here is 50-50. So that's
Okay.
what skewness means. For instance, if you have 50 girls, 50 males, and 50 females, this is normally distributed. But if you have more females than males, for instance, it is skewed to the what? To the right, meaning there are more females there. Or you can say it's positively skewed. If you have more males, the skewness will look like this. The word skewness is spelled like this. A skew. And statisticians want to use the skewness to give a perspective of how the balance is. Are we together? Anyone lost? Please speak now or forever hold your peace. Are we on the same page? Okay. All right, so now we go to what we call the interquartile range. Interquartile range is simply the difference between the upper quartile minus the lower quartile. So in this case, our upper quartile we calculated was what? 5. And the lower quartile calculated was 2. So 3 is called our interquartile range. Our semi-quartile range, anything semi means half. So if we're going to half our interquartile range, we're going to call this a semi-quartile range. So half of 3 is going to be 1.5. So this is called our semi-quartile range. Now, how do we identify outliers using this concept? So remember, we had 2 here, 2, 4, 5. We had a 10, right? So our interquartile range we calculated was 3. Then you multiply this 3 times 1.5 to get a correction term. It's a standard figure. So our correction term here will be 4.5 because we multiplied what? The 1.5 to this interquartile range. So this 4.5, you're going to treat it as follows. To this guy, you subtract. To this guy, you add. Any figures that are going to fall outside the range are called outliers. I repeat, after getting the interquartile range, multiply 1.5. You get the correction term, 4.5. So 4.5 plus the Q3, it is going to give us 9.5. So we find that 10 yabakunse. This 10 is out of range, it's called an outlier. Then we also go to this number here, the 2. 2, we subtract 4.5. It will take us to negative 2.5. So this 2 has survived, it's inside. So this is not an outlier. The 10 fell out. Outliers are very important because they give us a range to identify which outside range. For instance, when you come late for an exam, you're told that you need to be or let's talk about a flight. A flight which departs at 14 hours. Of course, is keep time. They'll give you a range, okay? Be there an hour earlier, but they'll give a range. Say, okay, if somebody's there at 13:45, they're early, maybe to 14:15. They may consider you to be within range. You come at 14:10, you're still late, but within range. But if you come at 14:16, and 14:20, you're an outlier, you're out of the range. Flight will leave you. Right? An outlier can also give a distributions of extraordinary events. You are the tallest in the home, the rest are short. You're an outlier. You would want to find out whether there is something that is distinctive about you. So this helps us understand concepts that we have in statistics. Data can later be regrouped in classes. These classes we could have as follows: 1 to 5, 6 to 10, 11 to 15, 16 to 20. So this is called a class. You could also have frequencies like 4, 6, 8, and 2. So remember how we came up with the cumulative frequency. It was simply an add-on. We start with a 4, add to the 6, get a 10, add to the 8, we get a 18, add to the 2, we get a 20. This 20 is our n. Now, this information that we have here can help us identify from the classes, we can get our height. The height is the difference between the bounds. 5 to 10, 10 to 15. Look at these bounds. We're getting a difference of what? 5. Don't get the difference between 5 and 1. You get it wrong because this is not adjusted yet. All right. You could also be able from this information calculate two things. Your mode. Mode stands for the what? The most frequent. I'll start with the basic formula. D1 plus D2. So you identify the highest number in this class. In the frequency, our highest number is what? 8. So the D1 is the distance above. So our D1 here is what? From 8 to 6, we get a 2. Our D2 is a distance below. From 8 to 2, what is the distance? We're getting a 6. Then using this 8 again, you identify the lower boundary. Now, ideally, this number must be the same as that number. If it's not the same, we usually subtract a 0.5. It is a rule. Let's go through it again. Chimuka, I said mode stands for the what? The highest frequency. So step 1 in identifying the mode is what? We're looking for the highest number. In this case, we found 8. This is our reference point. Upwards, we get the distance 1. Downwards, we get the distance 2. Using the same 8, we identify our lower boundary called L. If there was 10 here and 10 there, we get it as it is. If the numbers are different, just subtract a 0.5 there. So what is our L? 10.5. What is our height? 5. What is our D1? 2. What is our D2? 6. And our total distance is what? 8. So we just simply fuse up here. 10.5 plus D1, which is a 2. The total between D1 and D2 is 8. And the height, which is 5. So when you compute that, we're going to have 10.5, don't touch this guy yet until you rectify that. 2/8 is a quarter of 5 is 1.25. 1.25, when you add it to the 10.5, you're going to get 11.75. So this is how we find our mod. Don't abuse the calculator where you can use your head. This is the most dangerous topic. I usually don't encourage people to go for it in the exam phase because it wastes a lot of time. It is very bulky. But people find it easier than probability. That's true. So I lost a good number last year because I was cautioning. In fact, generally, school performance was not so good because people were rushing and leaving important things. I plead with you, those of you who are repeating either, and those of you who are doing for the first time, the school wants quality and the school wants you to follow precisely. So we're going to take our time. I need you to understand and ask all silly questions where possible, and let us stick to his notes so that we could really not deviate. Everything is the same. If the others could clear, you too can clear. I really want you to really give the attention it deserves. I know the calendar at school is so busy, but please create time for this course more than the other courses because it demands a lot of it. All right, I only have 4 minutes before lunch. Let me quickly do the median and then I'll give you homework. Is that okay? All right, median means the middle variable. All right.
Sorry, just come again on the L, and also the height.
Okay, the easiest way to finding the L, start with the height. I said the height, you just look at the bounds here, the distance between these numbers. It's constant. 20 to 15, 15 to 10, the height is 5. Even here, 10, 1 to 6, the height is just 5. All right. Avoid subtracting like this, subtract in the height direction. And the L, I mentioned polygons that are epitomized by the data here. This is like a bar chart because there's a gap of 1 between 5 and 6. So ideally what you're supposed to do whenever there's a gap, you are supposed to adjust the classes. So subtract a 0.5 there and add a 0.5 there. So here you're going to have 0.5 to 5.5. And subtract a 0.5 there to be 5.5. And here it will go to 10.5. And subtract here, we're going to have 10.5. And add 15.5. And here subtract 0.5 there, it is what? 15.5 to 20.5. Like that, you will not have any problems. So when you're being asked to find the mod, so the mod, you will use either formulas, the first one I talked about, or you use the long formula, which I can also take advantage of. So mod will therefore be equal to L plus Fm minus F1 over 2Fm minus F1 minus F2 times the height. So what is F1? What is F2? So when you're going into the table here, we identify highest frequency, we call it Fm. On top of it, F1. Below it, F2. In the same line, we look for the lower bound, which is this one, our L. So our L is 10.5, our H is 5, our Fm was 8, our F1 was 6, our F2 was 2. Altogether, in identifying this information,
Yeah.
Then we now substitute this information here. Our L is 10.5 plus FM is 8, F1 6 over 2, 8, 6 minus what? 2, and the height of what? 5. So we're going to get the same thing. When you compute this, you're going to get a quarter of 5. 10.5 plus 1.25, which is 11.75. The same answer you're going to get. So this is 2, and here you're going to get 16 minus 6 minus 2, we're going to get 8. So 2 over 8 is the same as a quarter. Are we together?
Yes.
All right. So we also can use the same data to compute or draw our histogram. Histogram, we use the adjusted figure that we have there. So from the adjusted figures, we're going to use 0.5, 5.5, 10.5, 15.5, 20.5. All right. So these, we use adjusted classes. You cannot get classes without using what? Adjusted figures. So also in the frequency, look for the highest figure there, it's 8, so that you come up with what? A good range. So 0.5 to 5.5, we get a 4. So this one goes up to a 4. 5.5 to 10.5, we get a 6. Then we have 10.5 to 15.5, we get 8. And also 15.5 to 20.5, we get a 2. So this is what we call our histogram. You also label it, it's important. All right. So you can use the upper bound against the frequencies to come up with the ogive. So
Mr. Kojo, here, I'm coming up with a histogram and use the lower bound.
no, for the histogram, you're using both. 0.5, you start from this one, 0.5 to 5.5. 5.5 to 10.5, you just use an L. Because just get,
Okay.
because it's a range.
I get it.
Yeah. Because the ending point is the starting point for the other. So you can even forget this part because they're already there. Are we together?
Yeah, sure.
Is this interesting? Are we learning something?
Personally, some
All right.
Yes.
So my people perished because of what? Lack of knowledge. So now we get these against the frequencies. So 5.5 against 4, you put 10.5 against 6, 15.5 against 8, and 20.5 against 2. You can come up with an ogive from here. Using the upper bounds against the frequencies. You can also come up with what we call the cumulative frequency curves, using the upper bound against the frequencies there. So 5.5 against 4, put there. 10.5 against 10, put it there. So this is 12. Can extend it there. 14, 16, 18. 14, 16, 18. So 15.5 against 18. 18 and 20.5 against 20. All right. So you are seeing how the cave is looking like already. This is the cumulative frequency. It is epitomized by what I told you. It doesn't fall. EF here. All right. So we've done all the caves that you need to understand possible. Any questions this far?
I have a question. If I'm right, the 0.5, 5.5, 10.5 are the midpoints for the classes, right?
Pardon? Yes.
The 0.5, 5.5, 10.5 are the midpoints for the classes.
No, the midpoints, we haven't calculated them. So even for the OGIV, you can use midpoint. So I'm following what he was using in class. The OGIV, you can also use the midpoint as well. So the midpoint.
Okay, so before you go further, where did the 0.5 and the 5.5 and the 10.5 come from?
Okay, can somebody tell me where we found these figures here? 0.5.
Those are the upper and lower limits. Like, kindly show me the data set again. Like
So
there we have 1 to 5.
if you have a data set, for instance, of 2 to 4, 4 to 6, 6 to 8, there's no need of adjusting because it's okay. But where I have a data set, for instance, 2 to 4, 5 to 7, 8 to 10. Okay, this is in a bar chart form. So according, we need to adjust it. So adjusted class will be subtract 0.5 there, will be 1.5, and add a 0.5 there, it's a low 4.5. And subtract the 0.5 there to 4.5, add a 0.5 there to be what? 7.5. Subtract the 0.5 from here to be what? 7.5, and add a 0.5 there to be what? 10.5. So now you can see that knife paranif. So this is exactly what we're doing here. When we saw that if that's paranif, we will have a problem. So we subtract a 0.5 from there, and a 0.5 we added there. So this is called the adjusted class. Is that clear?
Yes, it is. Thank you.
All right. So now I think it answers your question now, right? Where these figures are coming from. Although we're using the upper bounds against each of these ones to get the tabulated figures. Lastly, can I end here? Some people going back for work, isn't it? Or I can continue a bit. All right.
Can continue.
So we may also have information that may be given as follows. 0, 1, 0, 2, 0, 3, 11, 12, 12, 12, 21, 23, 24, 24, 26, 28, 31, 33. And you'll be asked to come up with what is called a stem and leaf diagram. Okay, so we have numbers that start with what? Zeros. And numbers start with 1, 2, and up to 3. For zeros, they're already arranged in order. Fortunately, we have 0, 1, the stem is already there, 0, 0, 2, and 0, 3. For the ones, we have 1, 1, 1, 2, That's 12. Another 1, 2. That's 13. Then 1, 3. Okay. And the 20s, we have 21, 2, 1. We have 2, 3. We have 2, 4. Another 2, 4. Then 2, 6. And another 2, 6. On the 30s, we have what numbers? 3, 0.
0, 1, and 3.
Okay. So this is how we draw the stem and leaf diagram. How many numbers are there? 1, 2, 3, 4. 1, 2, 3, 4. So n is 16. So using this data, we can go back to our initial lesson 1. Our Q1, who remembers how to find Q1? Q1 is what?
Q1 is a quarter of
N. So if our n is 16, what is a quarter of 16?
4.
If we get a whole number, we get that number and the next number that follows, we average them. So a quarter of 16 is the fourth number. So if we get a fourth number exactly, we get the fourth and the fifth number. Let's count 1, 2, 3, 4. So we also get the fifth number. What numbers are these? 11 and what?
11 and 12.
12. Right? We average them. So 11 plus 12 divided by 2, we get 11.5. So that is our quarter 1. Then we go to our quarter 2. Quarter 2 is also called what? The median.
median.
So what is half of the median? What is half of 16, sorry?
8.
So what do we do? We find the 8th number. We check on the 8th number and which number?
1.
And
The
the
9th.
9th number, you average them. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. So what two numbers are these?
21 and 23.
21 and 23. And when you average them, we're going to get what? 22. So this is called our median or second quartile. Then finally, how do we get the third quarter? Quarter 3, what do we get? 3 quarters of what? Of n. 3 quarters of 16. So that will be the 12th number. So what does this mean? The 12th number, we're going to get average the 12th number and the what? And the 13th.
13th.
Divided by 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. If the numbers are the same, you just maintain. There's no need for averaging because this is 26 plus 26 divided by 2. Still 26. Okay, a quick can you remember? When we find the difference between the first quarter and the third quarter, what do we call this? Quarter 1 minus quarter 3 minus quarter 1, what do we call it?
Interquartile range.
Interquartile range.
It's called interquartile range. So 26 minus the first quarter, which was what? 11.5. All right. So 26 minus 11.5, we're going to get 14.5. When we have the 14.5, who remembers what we get?
Semi-quartile.
The semi-quartile range, correct. Or the quartile deviation. So half of the interquartile range is called the semi-quartile range. So half of 14.5 is called what? A semi-quartile range. Okay. So we get
7.25.
Correct. Now, who remembers how do we draw the box whisker plot? There are 5 key parameters. Number 1, The 5 key things that are needed on the post-Whisker plot. Number 1,
the lowest value,
the lowest value of x, and
Q1,
the maximum value of x. Then
Q1, Q2, Q3.
Q1, Q2, and Q3. Excellent. What is our lowest value of x in this data? 0, 1, and 33.
1.
All right. 0, 1, and 33. Then what was our first quarter? 11.5, 22, and 26. 11.5, 22, and what?
26.
Sorry, Mr. Collins, you said if you have if you have the same numbers, you don't have to average them, like 26 plus 36.
26 plus 26. I'm saying it's the same figure, Heidi. Like 26 plus 26 divided by 2, we go back 26, the same number.
Oh,
Like 4 plus 4 divided by 2, it's still 4. So you don't abuse your brain if the numbers are the same. So can you tell me what type of skewness is this? Is it skew to the left or to the right? Here the difference is 4. Here the difference is what?
It's skewed to the left.
Skew to the left, yeah. Over 10.5, so it's skewed to the left, right? Correct. Then our interquartile range we had found as what? Interquartile range was what? 14.5. So how do we get the correction term after finding our interquartile range? That's 14.5. What do we do to it?
Apply 1.5.
Multiply it by 1.5. Excellent. 1.5, where is it coming from? It's a standard value. So when we multiply it by 1.5, we're going to get what? 21.75. Then what do we do to 21.75?
And subtract the lower quartile,
The row
add the upper quartile, find the outlier.
add it to identify. What is the purpose of this?
In order to find outliers.
Identify whether there exists an outlier. So when you add this one here, it's bringing us to 47.75. When we subtract that, 11.5 minus 21.75, we're getting negative what? Negative 10.25. So do we have any outliers? No, everything
No.
is inside, right? Everything is inside, so there is no outlier. Okay, so this is how I could summarize the first unit. And is there any questions?